Welcome back, guys. I hope all of you will be fine. So this is question 2.26 of our book, which is electric circuit by Nilsson, and the statement of this question is the current IA and IB in circuit in figure 2.26, which is this one. This is the figure, are 4 amperes and minus 2 amperes. Okay, so where is IA and IB? We can see here that this is IA, okay, and the value of it is 4 amperes. Okay, let me write it here. IA is 4 amperes and the value of IB, which is this current, that is minus 2 amperes. If the direction of it is here in this one, and this is what, this is minus 2A, so if the current is in the other direction like this one, if this is IB, so the only sign of it will be changed while the magnitude or the value of it will remain the same. So if I take this IB as IB prime here, so the value of IB prime is what? That is 2 amperes from the value of IB, which was minus 2 amperes. Okay, so from it we have got this IB prime. So you have got my point that if this was minus negative, so in the opposite direction the current will be of the same magnitude while the direction of it has been changed. Okay, so on the basis of it we have to find what? We have to find I of G, V of G. So this is I of G, this is V of G, and also find the power dissipated in each resistor. And I have previously told you that to find the power dissipated in each resistor here, that would be PR IR square multiplied by R. Okay, so this is one of the formula on the basis of the currents, on the basis of the voltage. That formula is VR square divided by R. So we can use any one of them, but here probably we will use this one, and for it the values of the resistors are given. What we have to find out are the currents in all of these resistors, and the part D of it is show that the power delivered by the current source is equal to the power absorbed by all the other elements. So means that this current source is the main power delivering element here. Okay, so now let us start it, and here let me first see that what are the things which are given. So first of all, let me point out some voltages and currents here. So the first, let me take this point, this point, this point. Okay, let me call this as the VA. Okay, this one as VB and this one as VG, which is already given. It will be the ground, which is here, and the currents here, which are, let me take this current as I of B. This current taking the direction here, this is I30. Okay, this is this one, and the current which is flowing through this one, that is I5. Okay, these currents are given. Now on the basis of our solution here, let me solve them all here. So first of all, let me find the value of V of A. As we can see that the current direction is in this way, that is IA. So therefore the polarity of it will be what? That would be plus minus here. Okay, because this is the passive element, and in passive element always the voltage will be dropped. So in voltage drop the polarity should be like it is from positive to negative. Okay, in this way VA will be what? If we apply the KVL here in this branch from it to this one, from VA to this one, in this branch it will be what? It will be VA is equal to 100 volts because of this voltage source, and we can see that these are the same polarities which are connected, so therefore it will be V15. Okay, the voltage drop across this 15 ohm resistor, so it will be VA 100 plus V15 is IA multiplied by 15, and the value of IA is also given, that is 4. So 4 multiplied by 15, and ultimately we will get the value of it is 160 volts. Okay, so this value is the value of VA is given now. Now in order to find the value of the VB, what do we have to do? We must have all these values. Okay, so here we can see that this is VA, this is VB, this is the applied voltage, while this one is the remaining voltage, while the consumed voltage will be consumed across this 9 ohm, 11 ohm, 10 ohm. So we can apply here what? We can again apply here the KVL. Let me apply here the KVL, so where it will be VA minus VB, which is the applied, minus the remaining, is equal to what? That would be the V9 voltage drop across this one, plus the voltage drop across this 11 ohm, plus the voltage drop across this 10 ohm resistor. Okay, so let me apply them. The value of VA is known. Yes, that is 160 minus the value of VB. The value of V9 is IB prime multiplied by 9. The value of V11 is IB prime multiplied by 11, and the value of V10 is IB prime multiplied by 10. So therefore IB prime is common in between all of them, so that is IB prime, and the values of the resistors by applying the Ohm's law here. Okay, so 9 plus 11 plus 10. Okay, so it is 160 minus VB, the value of IB prime is 2, multiplied by, it is now 30. Okay, so 160 minus VB, that is equal to the 60. Okay, finding it out, the value of VB is now what? That is 160 minus 60, so that is now VB is 100 volts. Okay, so the value of VB is also known. So this one, this voltage is now 100 volts. This is now 160 volts. These voltages are known. Now when this voltage is known, this is 0, we can find out this current, which is IB. That would be the potential difference divided by the resistors. So therefore the value of IB is what? That is VB minus 0 divided by the resistances, which are 4 plus 16, 20. Okay, so value of VB is 100 divided by 20, so that is 5 amperes. Okay, so the value of IB is 5 amperes. Now in order to find the value of I30, we can see here that there are two currents which are coming towards this junction or this point. These currents are IB prime, I30, and when these are combined together, it will give me this IB. Okay, so IB is equal to the I30 plus IB prime. Let me write their values. So the value of IB minus IB prime, that is I30. Okay, to find out the value of I30, let me write the value of IB, that is known, and that is 5 amperes, minus the value of IB prime, that is 2. So the value of I30 is 3 amperes. Okay, this current is now already known. Now this current is known, and to find out the value of this current, which is I5, what do we have to do? We must have the potential difference, which is VA minus VG. But now here, in order to find out this VG, we have this potential drop, we have this voltage. So again, applying the same formulation what we have applied here, we can write here what? We can write here VG minus VB divided by the 30, that is equal to I30. Okay, we can see that this is the potential difference divided by the resistance, that is equal to current. Now in order to find the value of the VG, it will be VG is equal to what? That is 30 multiplied by I30. Okay, and VB will be added with it, so that would be VB. Okay, so 30 multiplied by I30 is 3, okay, plus VB, so VB is 100. Yes, so that would be the value of Vg is now what? Let me calculate it. So this is 90 plus 100, that is 190 volts. Okay, so the value of Vg is 190 volts. Now when this voltage is known, we need to find out the current, which is I of G. In order to find out the current here, we need to find out this current, which is I of 5. Okay, so in order to find the value of I of 5, this voltage is known, this voltage is known. So potential difference divided by the resistance, that is I5. Okay, so let me write it here. So the value of I5 is VA minus VG divided by the 5 ohm, that is VA is 160 minus 190 divided by 5, so it will be minus 30 divided by 5, so that is minus 6 amperes. The value of I5 is minus 6 amperes. So when this current is coming towards this one, it is split it into two parts. One is I30, the other one is IG. So applying KCL here, let me use this point. At this point, we can see that I5 is equal to what? That is IG plus I30. Okay, the value of IG is not known while the other values are known. So therefore, the value of IG we have to find out, and that would be I5 minus I30. The value of I5 is what? That is minus 6, and the value of I30, that is already known, that is 3. So minus 3. So from it we can find out the value of Ig, that is minus 9 amperes. Okay, so the value of Ig is known, the value of Vg is known. To find out the other power dissipated in each resistor, we have to find the currents, and these are known. This current is known, this current is known. Okay, this current is known, this is known, this is known, all these currents are known. Okay, we can see that here we have found out all these currents. So applying this formula, we can find out the currents. Okay, for the last part, it is your assignment to see that whether this is the prime source or not. For the hint, for the sources, we can find out the formulation, and that is P is equal to IV. That is what? That is the power dissipated or developed formula for the sources, which are two sources here. One is the voltage source and the other one is the current source. If you have any question, you can ask me, and I will solve the part D of it as well in my next video. Okay, so that's it for today. If you guys have any question regarding the solution of this problem, you can ask me in the comment box. See you soon.